preparation, right? Right? Did you noted that? So it's very important. So before building a big AI tool or deploying your LLM, there is a question that you should ask, right? Is our data really ready? Yes. So this is our next session. Next session takes us from lakes to LLMs, building AI-ready data with Amazon S3 tables. To take the session, we are having two amazing speakers, Sai Purushot and Vikneshwara RB. Sai Purushot is a senior software engineer from Presidio with strong expertise across the AWS ecosystem. He focuses on designing scalable, cost-efficient architectures using services like Lambda, Glue, QuickSight, and Redshift. He loves automating.
Thanks for joining this session. Hope you had a great tea break, I guess. Yes, so let's quickly jump into our session here. So myself, Sai Purushot, and I've been there in Presidio for almost 3+ years, and I have the experience of building data platforms on AWS. And with my colleague here, Vigneshwara, he kind of like has a 5+ years of experience in Presidio, and he also worked on with building and modernizing data platform on AWS, Databricks, and Snowflake, etc. So that's our quick intro here, and we'll start with our topic here. So before going to agenda, right, today we are going to see about how we can build a modern data platform that can be consumable for AI systems, right, using an service called S3 tables. So before going into the topic, how many of you are here from data domain? Oh, super nice. So most probably you might be heard about a lot of medallion designs and I guess data vault architecture, these kind of things, right? So if you are new to data, so you will get some good insights from this actually. So we'll start with the agenda here. We are going to start with what's the AI gap today here, and also there will be like most of the enterprise AI starts adapting the lake-based systems. We are going to see about how it impacts the enterprise gates, and also we are going to see about what's the solution needs actually for the enterprise systems, and we are going to see about what the S3 table play a key role here, and we are going to see a use case here with a demo, and also at last we are going to see about the key takeaways here. So let's quickly jump into the problem statement here, right? So before we jump into the problem statement, in today's world, right, there are like lot of enterprise companies like Walmart, Flipkart, or even a mass enterprise scale company started using AI initiatives, right? Like examples, customer chatbot, product recommendation engines, and also a GenAI based chat assistants for analytic use case, right? So these kind of AI initiatives are start getting used by a lot of enterprise companies, right? So let's consider a use case for a large enterprise scale retail online store, retail company, right, where it has a lot of online store presence across the world. So for this company, let's consider a GenAI based assistant or a chatbot for a business intelligence or an analytics use case, right? So as a business user, I'm going to pitch in few questions to the GenAI chatbot, right? There are few questions. Let's consider an example. The first one will be like, what is the highest selling product of the year, or who is the highest paid customer of the year? So these kind of business intelligence question I will be asking to that particular GenAI chatbot, right? So in order to build these kind of products, right, so initially I will start with an MVP product, the base product for this basically. So when I try to build this and show to a leadership team or a business team, they will be like impressed with it, with the first setup basically. But that's not the real world, right? The bottleneck will begin when we try to deploy this applications at production scale, right? Let's consider a scenario where the leadership team or the business users start using these kind of products on a day-to-day basis, right? They will start asking these kind of questions on a daily basis, right? But if there is no proper data or proper data platform built, there will be like nuances actually. So what will happen, right? If a business user will ask the same question, but the LLM or the AI model starts giving a different answers for the same question, then the leadership or the business user will start thinking, right, whether my AI is smart enough or what's happening to my system itself, right? These kind of questions will start arise, and they will try to know about whether my data is itself is correct, or where the data is coming from, what's the source of truth, everything. All the problems will comes into play if there is no proper data platform for the AI systems, right? That is one of the major problem here. Not only with the AI system, let's consider for a engineering standpoint, right? So when we try to come into the engineering standpoint, there will be a lot of engineering teams for AI systems, right? The one person will work on with building a rack pipelines. There will be another set of team for building embeddings and optimization. There will be another team for ML systems, right? So instead of focusing on or optimizing the AI system, the engineering team will start focusing on fixing the data itself, right? They have to focus on data engineering fixes and schema fixes and everything. It will be like overhead for the engineering teams too. So these kind of problem will start when there is no proper data platform or data management that happen over at the data platform itself. And also, right, and also if we consider at the leadership level, right, so these kind of problems will lose us the confidence on the AI systems basically. So hence I would say the AI system mostly fail not because of the model but because of the data it resides basically. So that's how the problem will start from the enterprise adoption gap. So we'll quickly jump into how most of the companies will follow, right? So how many of you heard about lakes? Like anyone give about what is that lake? Yeah. Lake what? Yeah, just. Data lake, yes. Yeah, okay. So it's the basic data lake, right? So data lake we'll call it as like S3, right? So it's kind of like a blob storage where we'll dump all kind of data, right? We can able to store like the file formats, we can able to store video files, we can able to store audio files. We'll just dump all the data that it needs. So this kind of like data lake based storage will help us to store semi-structured and unstructured data, right? It's highly flexible. But there are some caveats around it basically. So it's highly flexible, I agree with that. But the problem is, right, it doesn't contain any proper table semantics or any schema informations, right? That leads to inconsistencies in the data, right? There is no transactional nature guarantee actually. And in case of enterprise-grade systems, there will be like a lot of data that comes into flow actually. There will be like a lot of schema drift happen, there will be like changes happen over the data, right? So without this, right, this schema evolution doesn't support in the data lake, it causes our data engineering pipeline to fail too. So these kind of problems also present when we try to use lakes for the AI systems. And also, right, and also there is one more problem called data auditability basically. So we have to have some kind of feature where we can able to see the data evolution over the period of time. So what happens over the data from last year to year. So these kind of like auditability features also not present on the lake basically. And last point is the governance basically. So since AI system can do anything, right, we need to have a proper control over to the AI system. So lake based approaches doesn't fit for the governance per se. So these are the challenges when we try to use lake for the AI system, right? Then what's exactly the enterprise really needs, right? They don't want just another tool. And they don't want the multiple copies of data, right? So when we try to use lakes, right? So if an enterprise team or a proper engineering team, they will be having a multiple pipelines. There will be like a separate pipeline for ML per se. There will be like a separate pipeline for analytics workload. There will be for Gen AI assistance too. So when we try to use lakes, we will be having a separate set of copies of data for the lakes. This also causes a problem. So in order to avoid that, the enterprise grades are these kind of like unified solutions that we need basically. So they don't want any other tools, they want a single unified solution which supports transactional nature, even the schema evolution support, which has to handle the data drift. And also there will be like a unified pipeline that supports for BI analytic workloads and also for AI systems too, right? And last but not least, the governance has to be enabled from the scratch itself so that AI can able to get more secure on the AI systems. So these kind of advantages that enterprise needs basically. So that's where we go over for a lake host based approach. So how many of you know about lake host basically before I jump into it? I think, okay, most of you guys know about that. So can you like anyone gives or share your experience on lake host building actually? Any experience on lake host? Okay, so Okay. So is there any pattern that you followed for building this Lakos?
So we go with medallion architecture.
Nice. Okay. And okay, so Databricks. Okay. Next, anyone, any other Lakos architecture that you have implemented in your projects or so?
Shift left is another approach.
Yeah. Okay.
Shift left. Basically, you process the data as and when it is getting generated. Slightly, moving towards the left is called as shift left.
Nice. This is the first time. Okay. Nice. This is great to hear. Nice. Okay. That's why we are coming into here actually. Yes. Nice. Anyone else apart from Iceberg, Databricks? How many of you worked on with Snowflake and etc.? Okay. Nice. One person. Okay. Nice. So Lakos, right? So I will give you a quick overview here. So Lakos is a combination of Lake plus Varos actually. So as I said earlier, Lake is a highly flexible. It stores semi-structured and unstructured data. But there are like some nuances as I said earlier. So, but in case of Varos-based systems, we will maintain a proper structure to it, right? So there will be like a proper structured layer where we can have proper consistency on the data. So how we can bridge these two to form a Lakos, right? That's where there are like lot of frameworks that are available which makes this Lakos plus Varos combination possible. So as I said, like the Databricks uses a Delta Lake framework basically. It's one of an open table format that can be easily usable for Lakos architecture. And there are like another frameworks like Iceberg and another one is Hoodie basically. So if you hear, you can go ahead and search for this in your own time. But these are the frameworks which are helpful for building this Lakos based architecture. But these are like open source frameworks, right? Managing from our end, it will be like hard, right? Then how we can manage it very easily, right? That's where the AWS comes into play here. AWS is gonna manage these kind of frameworks for us. So that's where we're gonna end up with a solution called S3 tables basically. It uses an Iceberg as its base layer, but it's gonna be completely managed by AWS. The framework is gonna be managed by the AWS. We are gonna just consume it for building a Lakos design basically. So what it offers really, right? So as I said earlier, it gonna supports transaction nature, right? What is mean by transaction nature or ACID complaint, right? So we can able to easily read, write, update, delete on top of a file system basically. Interesting, right? Even the file system is kind of like clumsy. How we do read, write or update, delete on top of this, right? So this kind of frameworks will help us to do, which makes our data more consistent for AI systems basically. And also, it supports schema evolution. The schema evolution is nothing but if there are any data drift that happens from our source, it is going to handle it very smoothly. We don't need to worry about that. And the third thing is the data auditability, which I'm speaking actually. So the data auditability is nothing but storing all versions of data in the system basically. So we can have a time travel feature. So we can go ahead and play back how the data evolve over the period of time. So these kind of advantages are present when we try to use these kind of S3 tables for our AI systems. And last but not least, it also supports governance. So there are like, how many of you heard about lake formation service in AWS? Super. So these kind of lake formation service can be easily integrated with S3 tables and which helps us to provide governance actually, governance and security per se for the AI systems. And also these S3 tables can be easily integrated with Glue, Athena, EMR, all the different services. So which makes S3 tables as our one-stop solution for building our data platform, right? So we are gonna see about a demo. Before going into the demo, I'm gonna quickly show about a medallion architecture. So if anyone has experience in medallion architecture, feel free to share what these three layer means actually. Anyone can give me like what is bronze, what is silver and what is gold. If you are from data domain.
Any volunteers?
Any volunteers? Yes, go ahead. Super. Nice. Good one. Anyone want to contribute? Okay. Okay, thanks guys. So as he said, right, so it's gonna be like some design pattern, that's it. So we are gonna follow this design pattern to make the quality of data improved, right? So we are gonna have 3 layers. The bronze is gonna be like a source of truth where basically where we'll just dump the data as it is from the source basically. We are not gonna alter anything. It's gonna be as equivalent to the source basically, just for our auditing purpose. It will have all the data from the source, we can able to keep track of it. So from there, we are going to move the data to the silver layer. The silver layer is going to be like highly cleaned and the filtered data, right? So it's going to be like little more modeled compared to raw basically. So it makes the quality of data even more good, and from there we are going to move the data to the gold layer where all the business logic presence basically, all the aggregations and everything we are going to have it in our gold layer, and that gold layer will be consumed for all the AI systems or analytics use case, etc. So while moving from these 3 layers, right, our data quality is getting improved. That's where this design patterns will really help. So by improving the quality of data, right, so we make the AI systems more accurate for the responses, like this analytics, business intelligence, chatbot or everything, it can able to give more answers in an accurate way. So by improving this data quality, we can able to build a proper AI systems, right? So we are going to see a demo on how we can build this for a retail analytics use case. So I'm handing over to Vigneshwara here, my colleague. He's going to continue this journey actually. Yeah.
Hope I'm audible till the last row. Yes, right. Thanks. So myself, Vignesh, I mostly like work on building a data platform and metadata-driven ELT related architecture. So Sai actually gave a base foundation on the reason for the build on the gaps in the enterprise AI, and how the differences between, I mean, a quick overview on the differences between a data lake and data lakehouse. Before moving to this architecture approach, I wanted to give an overview on the problem statement. So the problem statement is like we are trying to do a batch data processing for this scenario, but S3 table can be used for both real time also. Considering the, I mean, like the considering there are like more moving parts involved and the duration of the session, we are like focusing on the batch data processing. So let us assume that we have like multiple data coming, I mean sales data coming from various sources like CRM, POS related system or ERP related system. So in terms of these, the principle of the medallion architecture, the first layer we need is a landing layer. For this use case, we have used the S3 data lake, I mean S3 bucket as the data lake or the as the landing zone. So once we have the data in the landing zone, we are like going to like perform data transformation or data movement between the between bronze, silver, and gold layer accordingly. But for in terms of when we speak about moving the data or transformation, so in the AWS ecosystem, we are like we'll be mostly using this service called AWS Glue. So any Apache Spark, who I mean any professionals who are using Apache Spark are like aware of it. Yeah. Okay. So Apache Spark is a distributed processing engine in which like we'll be able to author our transformation logic in either like SQL fashion, or we'll be able to programmatically define our transformation, similar to pandas. If you are like used to like Python Python language, there is a library like pandas in which like you'll be able to create something called a data frame and perform transformation. In the same way, you'll be able to do it in Spark also, but you can able to use Python, Java, Scala accordingly. So in speaking of transformation, we are like going to like move the data from the source system to different layers using the AWS Glue only. There are like some configuration or technical components involved. I will try to simplify those and overlay the important aspects as well. So once we have this data in the gold layer, for our use case, since it is like a conversational chat interface, we are like exposing this data to this data is being exposed to an MCP server. So AWS have actually like launched MCP server for S3 tables, which we will be able to use that. So this MCP server serves as a bridge between the S3 tables that is available, which is managed by AWS, and the custom, custom chat application, or in this case, we have used Claude tool as an example. So this is a quick overview, and I will like overline each of them. So before going into the components involved, I'm hereby showcasing a quick overview about the S3 table data storage convention. So it basically follows 3-level naming convention. So let us assume something related. I mean, we can easily relate it with a traditional OLTP system or a database-related structure. So in database, mostly we'll be having a database name and a schema name and a table name. So in this S3 table concept, we have, so the database name, database name is something like table bucket, which is in the top layer, in which we will be able to store multiple schema and tables. And the second one is the namespace. In our case, it is something like retail DB, which acts as a schema for our, to hold our table-related information. And last, we have the table name which is available, which we will be able to create it using AWS Athena or Glue. So basically, the main advantage of this S3 table is like, speaking of these open table formats, any of the open table formats like Delta Lake or Iceberg or something like that, managing these metadata, managing data and metadata is crucial. And in generally, like if you have like used the lakehouse-based architecture, there is a classical problem called small files problem. So in which like our, behind the scenes, it will affect our transactional capability that was like conveyed earlier. So and there might be a scenario in which we might accidentally, there might be a scenario of accidental deletion of both data and metadata. In this case of using S3 table, both the data and metadata is basically managed for us. No infra. So as it is a managed service, no infra. We don't have to like provide any infrastructure related configuration necessary, and AWS takes it behind the scenes. So next thing is I'll give a quick overview on the transformation part or the glue job related configuration. So the key part is like we need a connector in that particular, the first place we need a connector. So it is like a jar file which giving in the, which will be trying to provide it as a configuration. So basically this jar file will be acting as a connector between our, for collecting the data from the source systems and performing transformations accordingly. So other than that, we'll be able to like create a Spark session using some of the so in terms of using Spark, there is some concept called Spark session, which acts as like entry point. In similarly, like in programming, we use something called main rate. Similar to that, this like in AWS, in Apache Spark, we have a Spark session which needs to be configured. So basically, to provide that configuration, we provide most of them are like boilerplate code, but one thing is the table bucket ARN that we need to provide and the path of the jar file. Once the Spark session is created, we'll be able to like interact with the S3 tables using the standard data frame related APIs, or in SQL also using Spark SQL. So this is a quick overview of the job definition. So giving a, to recap on the bronze layer basically, generally there would be a question like, why do we actually like store messy data, or why do we have a copy of the source? But in reality, like most of the systems have messy data available, and in most of the scenarios, what happens is like business logic can change quickly, or if there is any failure in the data processing or a bug is like discovered, we'll be able to reprocess or like replay the history data by using the bronze layer only. So in this case of like for this use case, I have like outlined
PPT
only the
PPT actually where a PPT but
sorry. Thank you. Um, so in case of the bronze layer that we have, so we have used only the overview. I mean, like we have considered only two related entries, like the customer related details and the order related details. So one, we are like trying to bring the data from the landing zone in the bronze layer. So once we have that, the next layer is the silver layer. So in terms of silver layer, so this is where this layer helps us to like prevent the business from taking into risky prevents the data in bringing like wrong outputs or incorrect ones, because here like the basic data modeling or the most of the data cleansing, data transformation, data managing, it can be like filtering records or handling deduplications, handling null values, or whatever the case. And once we have it, we can have actually like once we have it, so in this particular use case, it is something like these are our orders and these are our customers and how they relate to. We provide a basic structure or schema to the data, in which like we can provide also history related capabilities also. There is some concept called ACD type 2, in which like we will be able to like access historical versions of a particular transaction. So you'll be able to do that. So once this is available, so for our, I mean, for generally for a POC or related chat, I mean, if you are trying to build a chat interface at the POC level, we can like experiment with pointing our data to the silver layer. But our proposal is to like actually use the data in the gold layer. So gold layer is something. Gold layer is something where we try to. Gold layer is something where the data speaks the language of the business. So we have most of the business related metrics is defined, and it is morely it is being customized by the it is customized per business level metrics, and we perform data aggregation or data cleansing on top of the silver layer, so that we have the clear business metrics being defined. So here we'll be having an overview of for this use case, we have like outlined only the sales related information in the gold layer. So this is where the data in which we will be like trying to configure the MCP server. So before going into the configuration, I'll give a quick overview on the output that is available. So so the main crux is like using the S3 tables MCP server, which is like being which is being like exposed by the AWS. We are trying to point our S3 tables by providing MCP server configuration. So the MCP server is already provided by the AWS, and we are like trying to provide access control restrictions by using a AWS profile, which have the minimal in which we follow the least privilege principle possible, in which we try to provide only the read-only access using both IAM related services and lake formation services accordingly. And once in the configuration, it will be something like a JSON, in which we provide the MCP server and the profile of that AWS user basically. There the least privilege access will be implied using both the AWS lake formation and AWS IAM related services. So once we have asked question like what are our top customers or something like that, so before interacting with our system, we try to give a system prompt and trying to give an overview of the data as a system prompt. And after that, whenever we ask a question, so using this MCP server, so the data will be queried from the enterprise tables, and we'll be having both the SQL query will be executed, and the results will be displayed in a natural language manner. So the very important thing is like in terms of like whenever before the result is being generated, we generally have the query that being created that is being displayed. In terms of fine tuning our responses or like doing prompt related engineering, that is very crucial, and we will be able to like use that. Okay. So in terms of in terms of summarizing the topic for like how enterprise will be like able to make this S3 tables A ready is that we see that when comparing data lake and data warehouse, this lake house actually helps us to create a consistent data. So the schema history is basically preserved, or and the schema evolution is being taken care. In case like if there is any failure in the glue job, there is no corruption in the data, and any new columns that are added by the source system is handled automatically without any failures by this system. So the key takeaway is here is that in terms of the infrastructure cost, we see that the this S3 tables play a crucial role because instead of managing managing an open table format by us, so the main problem is that the managing of the data and metadata, we need to manage. There are various aspects like data compaction, managing managing them using like life cycles, policies, or so on. But S3, this particular service gives us as an out-of-box feature, and in terms of pricing aspects also, it is similar to a data lake only. But we have like transactional capabilities on top of that. In terms of speaking of the compliance or governance, we already have tight coupling with the lake formation service, which makes it much easier. So in this case of like in our approach of pointing our LLM chat interface or LLM system to gold level tables, we provide the LLM will mostly provide outputs in a trustable and a consistent manner. So finally, before wrapping up, the key takeaway that I wanted to like bring up is that AI doesn't need a separate data. It's not about choosing the best model or like just choosing the best prompt engineering related techniques, but it actually needs a better data foundation, which is used for explainability, traceability, and audit related purposes. So I will like pause here for any questions, or if you have any data lake related use case that you have like implemented also, you can actually share it.
Okay.
Hi. So yeah, nice presentation. So my doubt was like, if there is a single DB table and we are querying and we are getting the natural language output, we can like mostly get the output, and from the MCP server we can get the output. A is included and we can get the output. But my doubt is like, what if there are like multiple tables and there are like foreign keys? So is a single schema enough? If we are like embedding a single schema, is it enough to get the accurate outputs if we are using the S3 tables and all?
Okay, maybe I can take the question here. So it's about how we are designing the system, right? So as per your use case, right? So yes, S3 tables is not just a simple table. We can able to have a schema is related to a namespace here. So if you have a schema with multiple tables, you can create a similar namespace with a lot of tables here, but it doesn't enforce any scheme like foreign key constraint and all here. So it's our responsibility to maintain it. So it's kind of like a flexible way. That's why I say it's a lake house. It has lake features and warehouse up to certain level. right? So it's about our responsibility is to handle these kind of constraint, but it can support for lot of tables and also schemas and everything. We can able to classify and aggregate it basically for proper building of data platforms.
Okay,
Yes.
got it. So what if like data is coming on the fly and we have to like map it to multiple tables, foreign tables and all. So can you like handle that also? To
Okay.
get, yeah.
So are you asking about is going to be like batch data or live data, right?
Yeah, yeah. If we are getting like live data, and if I want to like, if like the sales customer you have mentioned, if the salesperson want to like use an MCP and then get the output, uh, can they like check the live data that is coming on the fly and?
Absolutely. Yes, that's a good question actually. So it's kind of just a metadata and data handling, that's it. So it's about what job that is going to run, right? Here in this case, I'm using glue job. There are like versions of streaming and batch processing. Here I'm using glue job for batch processing. You can even use stream jobs and you can ingest this data to these tables in a live manner and can be consumable for AI systems in a live manner too. We can able to do it. It's about how you ingest the data to these S3 tables basically. You can use like streaming jobs to ingest this data, or you can have a scheduled job to do this basically.
To add on, in terms of if we are like speaking about the streaming related data, it has a tight coupling with the AWS, Amazon Kinesis or a data Kinesis and managed Flink and Amazon SageMaker Unified Studio, in which we can configure it as a source and perform handle the metadata accordingly. And for this use case, we have like given overview only on a chat interface. But once the data is available in the S3 table, we can also create a agentic workflow also as needed. So
Got it. Okay, thank you.
Can we take the questions afterwards? You can meet the speakers outside or within the hall, anywhere. Thank you, Sai and Vignesh.
Yeah.
Thank you.